Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to apply impulse momentum methods. So what we're going to look at, or what we're going to do here, is we're going to take a look at this system here where this young lad is pushing on this car with a force of 200 newtons. And he does so for a time frame of 10 seconds. And what we're going to do is try to calculate the final velocity of the car and the distance that the car travels during this 10-second time frame, assuming friction can be ignored acting on the car. Now, methods of impulse momentum. Impulse is the quantity that changes your momentum. So whatever your initial momentum of a system is, plus any impulse added to the system, that equals your new momentum, mv final. This equation really is just Newton's second law, kind of twisted sideways. Notice if you solve this for F, you would subtract the m v sub o and then divide by delta t, and you'd have F equals m, basically delta v over delta t, which is Newton's second law. Momentum methods really are just kind of looking at Newton's second law kind of sideways. And again, this quantity here, force times time, has a special name. It's called impulse. So in this example, when we're looking at the impulse, you always start with a free body diagram because impulse is very, pretty much directly related to forces. It's force times time. So I'm going to go ahead and draw a free body of the car. So we've got, the gravitational force acting down, mg. We got a normal force acting up. And then we have this 200 Newton applied force acting to the right. So I'm going to go ahead and draw that over here. And I'm going to put that up where he's applying that force. Now, even though, again, I put it to the right, that 200 newtons, that's the force, that's the person pushing on the car. So don't add another force vector here. Now, if there were friction in this problem, that force would go along the tires and it would be to the left, but I assumed it away for this video. Now what I'm doing is I'm going to apply this impulse momentum relationship here, which basically says this, the initial momentum of the system plus the impulse equals the new momentum. Now, the F delta t here, these two forces add to 0. So this is the net force acting on the car. So this F, I'm going to use 200 newtons. The 10 seconds is going to go here. And the car presumably starts from rest. So the initial momentum is going to be 0. So this equation, by the time I write it all out, we're going to have 0 plus 200 newtons times 10 seconds equals mv final. The mass of this car is 1,200 kilograms. I made that up. The final velocity we're going to know in a minute. So that's what this momentum equation has to say about this car acting under this external impulse, or this external force of 200 newtons. If I solve that for the v final, what I get is about 1.67 meters per second. Boom. So there's the final velocity, 1.67 meters per second to the right. Now, to get the distance traveled, there's a couple ways to do that. I'm going to go ahead and do what I usually do. I'm going to start with a velocity graph when I analyze the motion of a particle. So velocity against time. Now, take note that at t equals 0, it's not moving yet. 10 seconds later, the car is going 1.67 meters per second. I'm going to put that point here. This would be pretty much linear because you'll notice that this force is constant. None of these are varying with position or speed or anything. So constant force yields constant acceleration, which means that slope is going to be constant. Distance traveled is going to come from that area right there, 1/2 times 10 seconds times 1.67 meters per second. What I get is about 8.3 meters during this time frame. So again, this was just meant to be a very simple example of how to apply impulse and look at how it changes the momentum of the system. And in this case, we use that to calculate the final velocity of the system, and then we use the final velocity to calculate the distance. Hope this helps demonstrate these concepts. Have a great day.